So let's start talking about long multiplication and division, especially with 6. So now first of all, let me remind you that these algorithms that we developed, so we developed the long addition algorithm, things like maybe 245 plus 176. And what we did was we had the ones, tens, and hundreds, and then we added it in a very intelligent way. We just said 5 plus 6 ones is 11 ones. We're going to keep 1 1 here, and then we're going to convert 10 ones into 110, and now we'll have 4 tens and 7 tens and 110. That's going to, if we add all of them up together, we get 12 tens. So we're going to keep the 2 tens here, and the 10 tens will get converted into 100. That's going to be 100. So now we have 200s, 100, and 100. We have 400s. So the answer is going to be 421. This is the long addition algorithm. Then we have the long subtraction algorithm. So let's try the long subtraction algorithm. Maybe what we can do is we have 345 minus 174. Okay, so what we can do is, again, we have the ones, tens, and hundreds, ones, tens, and hundreds. And again, what we can do is, well, we have 5 ones and we want to eat 4 ones. Well, we can certainly do that and we'll be left with 1 1. But now in the next phase, we have 4 tens and we want to eat 7 tens. It can't be done. So what we do is we take 100 and convert, out of the 300s, we take 100 and we are left now with 200s. Now 100 will get converted into 10 tens. We already have 4 tens, so that will make 14 tens. So 10 tens will get added to the 4 tens to make 14 tens. So now this will become 14. So we're going to interpret this as 14 tens. And 14 tens, we can certainly eat 7 tens out of 14 tens and we'll be left with 7 tens. And then out of the 200s, we eat 100 and we're going to be left with 100. This, along with these are the long addition. This is the long addition algorithm. This is the long subtraction algorithm on the right. And then we're going to talk about the long multiplication and long division algorithms. These 4 algorithms are really the heart of why place value is cool. So place value is so cool, right? So place value is cool because of these 4 algorithms, because they make computation efficient. So the computations are extremely efficient. And if you don't believe me, try doing these computations with the Roman numeral system or the Babylonian numeral system. Place value is just hands down better at doing all the computations. Okay? So let's move on and remind ourselves of the long multiplication algorithms. So let's see, we have 285 being multiplied 6 times. So the first thing that you want to remind yourself is you need to know your tables. So a critical thing is, I'll write it down, learn your tables. There is no shortcut to it. There is no way around it. Learn your tables. It is absolutely critical. Okay. So now I'm going to read, since I'm multiplying and I can multiply because of the commutative law, instead of reading it as 285 multiplied by 6, I'll read it as 6 multiplied by 285. I'm doing the left problem first, okay? So 6 fives are 30, I know that much. So 30 means I'm going to keep, so this is a ones place, so 30 is going to be, so I'm going to show the 0, which is showing the ones, but now the 30 is going to become 3 tens, so I'm going to keep the 3 tens right over here, just as a reminder that I have 3 tens. Now, 6 multiplied by 8 tens, please note, this is what I'm doing 6 multiplied by 8 tens. Now 6 8 tens is equal to 48 tens, right? Just like 6 8 apples is 48 apples, because if I take 8 apples and add them 6 times, I'm going to get 48 apples, because 6 8s are 48. So if I have 8 tens and if I take them 6 times, I'm going to get 48 tens. So with the 48 tens, please remember I have 3 tens that I've stored away. So 48 tens plus 3 tens will make 51 tens. So with the 51 tens, I'm going to put the 1 here and the 50 tens, because remember I had 51 tens, and the 51 tens, I keep the 110 here, and the 50 tens will get converted into 5 hundreds that I store over here. Now 6 200s will make 12 hundreds, and 12 hundreds plus 5 hundreds, these 5 hundreds will make 17 hundreds that I will write 7, and I will write a 1 here because I'm going into the thousands place, but this is 17 hundreds, right? So these two, please remember, if I have them, so these will be interpreted as 1700, 10, right? And please remember the 1 came because I added 3 tens to it to make 51 tens, right? I'm just trying to explain the why is the 1 here, and then the 1 came here, and the 5 and the 50 tens got converted into 500s. Okay, now let's do the same a different problem on the right. So let's do it together. Now I know 6 2s are 12, so I'm going to keep the 2, and the 10 ones will get converted into 110 that I'm going to store right over here. Now 6 multiplied by 7 tens, so just as over here, is going to be 42 tens. And 42 tens added to this 110 will make 43 tens. So I'm going to show you the 3 tens over here, and the 40 tens will get converted into 4 hundreds. And now 6 400s is going to make 24 hundreds, and then I'm going to add the 4 hundreds here to make 28 hundreds. So this will make 28 hundreds, and please note that these two numbers, right here, I'm reading it as 28 hundreds, which is also the same as 2800. Okay, just as I could read this as 17 hundreds. Okay, so this takes care of long multiplication.